In this video, I'll be solving this 1997 AP Calc AB exam. In this year, they split up the multiple choice into a no calculated portion and a with a graphing calculator required portion. Okay, so in this video, I'll probably solve most of the problems in this no calculated portion. I'm not sure if I'll finish it, but we'll see how the time goes, okay? And as always, I'll give my usual disclaimer to check whether the content covered in this exam is relevant to when you're taking this course. Okay, they might have removed some topics, they might have added some topics in and all that. So I'll leave that up to you. This is just good practice for solving problems that you should know how to do if you're taking AP Calc AB. They don't change it too much. There's always certain topics that they might move in or out. Okay, so let's begin this no calculated portion. We have number 1, we have this integral 1 to 2, 4x cubed minus 6x dx. This is just simple power rule, so that would be what? X to the 4th minus 3x squared. We evaluate it from 1 to 2. Okay? Now we just plug in 2 to the 4th is 16 minus 3 times 2 squared is 4 minus parentheses 1 to the 4th is 1 minus 3 times 1 squared, which is 1. This is 16 minus 12. This would be minus negative 2 or plus 2. So that's 16 minus 10, or that is 6. Moving on, f of x is x squared root 2x minus 3. F prime is, we need product rule. First, d second plus second, d first. So first, d second, what's the derivative of the square root term? It's 1 over 2 root 2x minus 3 times derivative of 2x minus 3. That's just 2, okay? Plus second, d first, derivative of x just 1, okay? So we have this. We can see these 2's can cancel. Now we have what? We have x over square root 2x minus 3 plus square root 2x minus 3. Okay, so how can we get it into a matching form? Let's just make a common denominator. So let's multiply this term by square root 2x minus 3, divide by square root 2x minus 3. When we do that, we get what? We get x plus the square root and this square root, the square root would go away. So x plus 2x minus 3 over square root 2x minus 3. So on the top, it should be 3x minus 3. Okay, that's how we do that. We have integral from a to b, f of x dx is a plus 2b. Then integral from a to b, f of x plus 5 dx is, well, we can break this up into two integrals by properties of integrals. So integral from a to b, f of x dx, plus integral from a to b of 5 dx. Okay, so let me continue up here. This guy we know is a plus 2b. Okay, this guy would be what? The 5 is a constant. After fundamental theorem calculus, we get b minus a. Okay, so we just simplify from here. It'll be a plus 2b plus 5b minus 5a, or that is what? 7b minus 4a. F is this guy. F prime is, this is just power rule. So F prime would be, this is minus 3x squared. This guy would be plus 1. This one would be minus 1 over x squared. We evaluate at x is equal to negative 1. So that's just what? Negative 3 plus 1 minus 1, which is negative 3. 4 is D. Okay, pretty easy so far. Graph of y is this whole thing is concave down 4. When it talks about concavity, that should signal second derivative. So let's find y prime first, and then after that, we'll find y double prime. Y prime is what? Power rule, 12x cubed minus what's 16 times 3. Maybe let me just write it in like this. Maybe things will factor out. X squared plus 48x. Okay, so that's that. And we have to find the second derivative, so y double prime would be what? 12 times 3, that's 36 x squared minus 16 times 3 times 2, that's 6. So let's write that like that, x plus 48. Okay, let's set this equal to 0. Okay, so what can we factor out? I see we can factor out a 6. So that'll be what? 6x squared minus 16x plus 8. Okay. I see we can factor out 2. So it'll be 6 times 2 times, that'll be 3x squared minus 8x plus 4. Hopefully I'm doing this right. And then we can factor this as 12 times, it'll be 3x and minus x minus something is either 4, 1 or 2, 2. So where do those go? It would be 1 and 4, I believe, because minus 3. That doesn't look right. So it would be, it'll be 2 and 2. So it'll be 2 and 2 because multiply that will get 4 plus 4. We got minus 6 and minus 2. Okay, there we go. So our critical points are x is 2/3 and 2. So we do our second derivative test. Okay, 2/3 and 2. We plug in some number much less than 2/3, like some huge negative number, or even 0. We can plug in 0. This would be negative, this would be negative, 2 negatives make a positive. Plug in some number in here, like 1. This would be positive, this would be negative, the sign's negative. We plug in a huge positive number, this would be positive, this would be positive, 2 positive, make a positive. Concave down when it's between 2/3 and 2. So 5 is E. Okay. We have this integral of half e to t over 2 dt is what? Hopefully you can see it right away. It's just e to t over 2 plus c. Okay? If not, you can do a substitution. U is t over 2. du would be half dt. So our integral, we have a half dt, so integral becomes e to u du, which is e to u plus c, or e to t over 2 because we had to back substitute plus c. Okay, hopefully this was a very easy substitution you should be able to do in your head. If not, and you can always just differentiate all these to make sure that you get this guy. Okay, that's a different way. All right, derivative of this guy. Okay, you have to be careful. We need the chain rule. Okay, so a different way to write this, if it helps you out, would be cosine of x cubed. Okay, that's this guy, and then this whole thing squared. Okay, if that helps you to visualize going outside in. So we start from the outside, we need the power rule. 2 cosine of x cubed to the first power times derivative of cosine, which is minus sine of x cubed times derivative of x cubed, that is 3x squared. Okay, so we should get what? This would be a 6x squared with a negative sign, cosine of x cubed, sine of x cubed. Okay, and that looks like this one. Okay, moving on. A bug begins to crawl up a vertical wire at time t is 0. The velocity v of the bug at time t is between 0 and 8, is given by the function whose graph is shown above. So this is the velocity. At what time t does the bug change direction? When velocity changes sign, that's when it changes direction, meaning if its velocity is positive, it's traveling forward. If the velocity is negative, it's traveling backward. So the velocity changes sign at t is 6. So that's where the bug changed direction. Okay. Now over here, what is the total distance the bug traveled from t is 0 to t is 8? Okay, so I'm going to do it up here. Total distance traveled. Okay, so we have to integrate the absolute value of the velocity from 0 to 8. Okay, So integral, that's just area under the curve. So we can find the area of this and the area of this. And we, instead of making this a negative area, we make it positive because absolute value. Okay, so that would be, well, what's the area of a trapezoid over here? Or if you want, you can even break this up to a triangle, to a rectangle, to another triangle, and then another triangle. But if you remember the area of a trapezoid, that makes things faster. So area of trapezoid is average of the bases times the height. So this base is 2. This base is 6. We divide it by 2 to average them, times the height, which is 3. Okay? And then we add the area of this triangle. That's half the base, which is 2, times the height, which is 1. Okay? So this is what? This is 8 over 2 times 3. So that would be what? That's 4 times 3. That's 12, right? This one is plus 1, so that's 13. Answer's 13. Equation of the line tangent to the graph of y is cosine 2x at x is pi over 4 is what? Tangent line. Equation of the tangent line to find the slope of that tangent line, that's derivative. So y prime would be minus sine of 2x times 2. Evaluate at x is pi over 4. What do we get? Sine of 2 times pi over 4, that's sine of pi over 2, which is just 1. Okay, so we get minus 2 as the slope. We have a slope. Do we have a point? We have the x-coordinate of the point. So what would the y be when x is pi over 4? That's cosine of 2 times pi over 4. So cosine of pi over 2, which is 0. So we have a slope, we have a point, we can find the equation of the line. Y is equal to negative 2x minus pi over 4. Okay? 10 is E. The graph of the derivative of f is shown in the figure above, which the following could be the graph of f. Okay? Well, since this is f prime, we see that it changes sign from at x is negative 2 and x is 2. And in fact, it went from negative to positive. So we know that f should have a relative, it went from negative to positive, so relative min at x is equal to minus 2. Okay, and similarly, because the derivative went from positive to negative over here, there should be a relative max at x is equal to 2. So which one is that? That looks like E. Okay, let me even confirm. Yes. Okay. At what point on the graph y is half x squared is the tangent line parallel to the line 2x minus 4y is equal to 3. Okay, so let me squeeze it up here. Here, when it says we want the tangent line to be parallel, so we need the slope of this guy. This is the tangent line. We want the slope. Okay? So to get the slope of this line, let's get it in slope-intercept form. So minus 4y is equal to minus 2x plus 3. So I just move this 2x to the other side. Y is equal to, we divide by negative 4 on both sides, half x minus 3/4. Okay? So we want so we know the slope is half. We want the slope of the derivative of this guy, because derivative is slope of the tangent line, to be equal to half. Okay? So let's find the derivative of y. So y prime is what? That's just simple parallel. That should be x. Want that equal to half. That's easy. X is equal to half. So what's the y value? Okay, so we can eliminate 1, 2, 3 already. What's the y value? We just plug back into here. It'll be half quantity cubed, which is b, the eighth. Okay? We're cruising along. Let f be defined for all real numbers x if f prime is this guy, then f is decreasing on the interval what? Okay, so I worked this out before. We just want to do the first derivative test. It's as simple as that, because it's asking about when it's increasing and decreasing, or decreasing, okay? And the first derivative test tells us that. So this is f prime. We just need to get our critical points. We know that the easy one is when this is undefined. That's when x is 2, okay? We know that when x is 2 or negative 2, the top is 0. So we have the critical points of 2 and negative 2, okay? So we do our first derivative test. We plug in some number less than negative 2, like some huge negative number. Well, we know the top is always positive because it's absolute value, okay? So positive divided by a huge negative number is negative. We plug in some number in between negative 2 and 2, like 0. 0 divided by 2, that's 0 minus 2, that's negative 2 at the bottom. Remember, the top's always positive, so negative again. Plug in a huge positive number, the bottom would finally be positive, so it becomes positive. So f is decreasing when the derivative is negative, so that's when it's less than 2. 13 looks like A. Okay. Let f be a differentiable function such that f of 3 is 2 and f prime of 3 is 5. If the tangent line to the graph of f at x is 3 is easy to find an approximation to a 0 of f, the approximation is what? Okay, so we're just going to use this tangent line that we're going to find and see where it crosses the x-axis. As simple as that, okay? Linear approximation, okay? So I also did this beforehand. You get it out. So we have a slope, we have a point, we can find the equation of that tangent line. Okay, so I use point slope form. Y minus the y coordinate, which is 2, is slope times x minus the x coordinate, which is 3. So I just put it in slope intercept form. Y is equal to 5x minus 15 plus 2, which is 5x minus 13, okay? A 0 is when y is 0. So I set our tangent line equal to 0. So 0 is equal to 5x minus 13, so I solve for x. That's simply 13 over 5. Okay, now what is 13 over 5? You don't have a calculator in here, in this part of the exam. Okay, so which one would it be? Well, I know that 10 over 5 is 2 and 15 over 5 is 3. So it's between 2 and 3, so it has to be C. Okay. The graph of f is shown in the figure above. Which of the following statements about f is true? Okay, so is limit as x approaches a the same as limit as x approaches b? As x approaches a, it's 2. As x approaches b, well, the limit from the left does not equal limit from the right, so this limit does not even exist, so cross that out. Limit as x approaches to a of f is 2. Yeah, because limit from the left is 2, limit from the right is 2, so it's also 2. Okay, so this is probably true. Let's check the rest. Limit as x approaches b, we said it does not exist, because limit from the left does not equal limit from the right. Does not exist again. A, we've said it exists, so B. Okay, and actually I'll call it a part here, so please like this video if you found it helpful, and please subscribe to the channel to be notified for the next part.